Sorry about that. So my name is Steve Gallagher. I'm with Red Hat, and today I'm going to talk to you a little bit about system manageability. But I'd actually like to start by asking you guys a couple of questions. So how many people here have ever had to manage a Linux server? Not surprising. Now, has anyone here had to manage a Linux server where they needed to modify storage in a running system? Okay. Would you be willing to share an example? Something you had to do, a real-world example. I can find someone else if you're being put on the spot.
Expand partitions from space.
Okay, great example. Great example. Very briefly, how, actually, let me get you a mic because I think they're recording this. How would you, very briefly, what would be the steps you would do on a Linux server to accomplish that task, to extend a partition?
Back up, read the manual page because it's not something I do very often, and then do it. I think I normally use a LVM resize, or I can't remember the commands are, and then the ext whatever resize.
Okay, thank you. No, that was fantastic. Thank you. So, and let me change gears a little bit and ask a similar question. Who here has ever had to modify networking on a production system somewhere? Would you mind sharing an use case, an example?
Sure. So an example is setting up firewall filters for a networking interface on a public web server. Does that count?
Sure. That's a good example. But actually, would you mind providing a very brief detail as to how you would do that?
Oh, sure. You start by going to Google and typing in, where's the config file for whichever networking filtering package you have, like IP filters or whatever, and follow the instructions there and hack on it until it works.
Thank you. Apparently, you're reading ahead of my slides. So let me recap that just slightly. So with storage, right now in a current system, pretty much what you're going to be doing is you're going to be hacking on, you're going to be executing a set of very specific command line tools on a shell on a system. PV create, PV extend, MD raid, MD ADM, et cetera, and so on and so forth. Now, that's the way things are done. It's just understood. That's how they're done. Now and then, of course, there's networking, where you've got the classic method, which, as you described, was hack on a bunch of config files until you get it right. Or in very, very recent systems, we also now have an NMCLI, a NetworkManager command line interface to do configuration of networking settings on the system.
Also the benefit of acting like God in front of non-users.
Actually, I'm going to talk about that. I am going to talk about that.
Is it the first time you do remove NetworkManager?
No, and I'm going to talk about that too. Be patient. So I want to ask, when I just described to you how you do your storage management and your network management on a system, did you notice anything about it? Anything in particular? The first thing to notice is that both of these methods involved specific local shell access to the machine. You had to, in some way, have a local shell or an SSH session into a remote machine to do any reasonable work on it. The other flip side of that is there was nothing in common between the way that you set the configuration for storage and the way that you set the configuration for networking. At no point do they have any overlap except Google. Actually, even that is a third approach. that's more of a chimera than it is anything else. Now, one thing that a lot of people don't, I mean, and there are reasons for this. I should go into that first. There are reasons why storage and networking and all of these other subsystems have very different configuration schemes, and that's because they all originated as their own unique projects with their own unique communities and their own view of how do I do the thing that it is that I want to do and that you want me to do. And for each and every one of these approaches, it makes sense in their particular ecosystem. It makes sense that, well, I'm going to write scripts to do networking. It makes sense that I'm going to have all these procedural commands to create and modify storage. But what people don't realize once you get to the point of creating an operating system, and creating an integration point of all of these technologies, is that each one of those separate configuration mechanisms is, in fact, a training problem. The real problem with the way that we do things on Linux right now is that when you learn how to build up a storage array, how you learn to build up a RAID array and LVM on top of that, and Gluster, and all of these other fantastic technologies that I'm sure you're discussing in all of these sessions today, the problem is that administrator that has learned how to do that now has exactly zero knowledge that they can take to any other subsystem on the operating system. That they really don't have any view of, well, okay, so how would I then go and configure a network bridge or a network bond? Or how would I set a default route on a network? Or how would I define what my system services, or which system services I have that are running? So each and every one of these steps is a completely brand new training exercise, and it's one of the reasons why a lot of people customers, a lot of organizations that use Linux acknowledge that they have a very small pool of people who can administer their Linux systems because they have to be masters of a great many trades. I mean, just for some examples beyond the ones I gave, we've got services, we've got firewall, we've got system software, we've got what is installed in your system, which patches, how are we going to do performance tuning, how are we going to do database tweaking. All of these things are very real and very, very different training costs to an organization. A couple of years ago, a group of us at Red Hat did a customer tour. We went and we spoke to, I think the organization that spoke to some 200 customers, and overwhelmingly, about RHEL usability and what it would take to get you to use more Red Hat Enterprise Linux, and overwhelmingly the answer was, well, the problem is we can only hire really expensive admins to manage it. We can't get anybody out of college to pick it up and say, okay, I can do the basic admin tasks. It requires so much training and so much experience to get to the point where any company would be willing to have you managing their production systems, that it is actively and seriously impacting their ability to consume more Linux. So how do we solve that? What do we do to get around that problem? How do we make it easier for new system admins to learn all of these new technologies, to be able to reuse them as they learn new ones? And so in the last year, Red Hat has started a new project called OpenLMI, the Open Linux Manageability Infrastructure. Now, the goal of this infrastructure is to be the one place you go, the one public API, network accessible API for managing the hardware and the system state of your Linux systems. Now, it's important to note, like I called out before, most of Linux configuration at this point, even scripted Linux administration, basically amounts to run a script through SSH. Use a set of local tools on the machine to run a particular set of tasks. This makes it very, very difficult to push out a series of changes to a lot of machines, and to do so in an auditable way. So one of the core tenets of the OpenLMI project is make absolutely sure that anything we can do both locally and both remotely. The next tenet is everything we do, we want to do it the same way for all subsystems within reason. All subsystems are going to have special cases, and they're going to have specific things that are to them. But in general, what we want is to be able to say, I'm going to use the exact same remote API and the exact same set of thought processes to accomplish whatever it is I need to do on that system. So we also, some of you might or might not be aware, a couple of years ago, we had a project that we were working on called Matahari, which failed. And one of the main reasons that it failed was that we were attempting to create a brand new series of standards for how to do management. And the world was not ready for that. The world was not willing to take that on. So when we started the OpenLMI project and we started looking at where we went wrong with Matahari, and what we decided was that we were going to build OpenLMI on top of established standards rather than trying to create our own new problem. So I'm going to talk a little bit about how we're doing some of this under the hood, and I'm going to start with the storage discussion. When we started the OpenLMI project, we started to look at what do we need to do under the hood. What do we need to have there that we can interact with, that can make sure that we can set up storage, that we can access a block device, that we can create an LVM partition, that we can partition a disk at all, that we can create a RAID array, and that we can do all of these things that you can do with these command line tools. And we took a look at what tools are out there to do, a coherent total system view of this process. And what we found was that we don't have any. We really don't have any tools that cover all the entire gambit of what you can manage in storage. What we did discover, though, a little bit surprisingly, was we had something that came close, but you couldn't use it on a running system. And what that was the Anaconda installer in Fedora and Red Hat Enterprise Linux. Because naturally, when you're installing a Linux system, you need to be able to produce the storage configuration necessary to actually put software onto it. And as we were developing that, we realized that Anaconda had this internal storage library that was completely unrelated to anything else, or was very minimally related to what else was on the system, and was more full-featured from beginning to end than anything we had in any GUI on any platform out there that I've looked at. So what we did was we approached the Anaconda folks, and we asked them, can we take this? Can we split this out and turn this into an API that we can use at any phase in the process? And it took some back and forth and some discussion, and certainly some cajoling, because it would require them to support it for additional use cases. But what they agreed to was that yes, it does make sense to have the grand unified storage management tool. And so we created the Blivit project. And if you want to know why it's called Blivit, you can ask someone on the Anaconda project. But because it's split off from Anaconda, it's a Python library with a surprisingly simple interface that can really do just about anything you can do with the command line tools, up to a point. And I'll talk about our limitations a little bit later on in the slides. So that got us to storage, but we had other concerns, and this is where I'm going to talk about not uninstalling NetworkManager, for example. So historically, NetworkManager got a bad rap because it really did start life as, well, this is how you configure your Wi-Fi card on your laptop. It very much got pigeonholed as a desktop-only service. over the last couple of years, the NetworkManager upstream, particularly driven by Red Hat, but also by Canonical and SUSE, have really put a lot of effort into enabling a lot of enterprise use cases such as bonding, bridging, VLANs, specialized routing tables, direct modification of the NICs, and all of these fancy, really cool and really powerful things that you always used to have to do with network scripts. The difference is that with NetworkManager, they provide you access all of this through a dbus API that guarantees internal consistency. Gone now are the days where you modify one of your network scripts and you suddenly discover that you are attempting to bind two NICs to the same bonding interface, and now you can't get into your machine. And the real benefit here is the consistency. We have a single API for doing all of this work, and it's one project's responsibility to make sure that all of those details are worked out. So we've been working very closely with them, and right now I believe that with NetworkManager 0.9, basically all of the functionality we are looking for in enterprise level networking control is available, and most of it works. There are still a few pieces that are getting worked out, and those will be ready in time for Fedora 19 or Fedora 20, one or the other. And moving on from there, so those were the two big pieces. Those were the two things that people had the most trouble with. So then we started moving down the stack because we wanted to have more than just these two pieces in OpenLMI. So we started talking about, well, what else is important to customers? And one of the very big, very popular ones was, well, I want to know, are my system services running? Have they crashed? Can I restart them again? And can I do all of this without having to maintain an SSH connection to all of my machines at all times? And so we took a look at that, and we realized, oh, we can do a lot with systemd, which is relatively new on the scene. I know not all of the distros have picked it up yet. I know Debian, or Ubuntu at least, is holding out against it. But a lot of them have come around to realizing that yes, while it is a big shift, the power that it brings to managing system services and to managing journaling services and to structured logging really were benefits. And so with the OpenLMI project, we realized, okay, we can use some of the systemd functionality to get really powerful monitoring of services and control over services. I can tell, with OpenLMI and with systemd, we can now tell absolutely that a bank of machines that is supposed to be running Apache, that Apache is running on all of those machines. And if it's not, we can also write code that very easily says, if it's not running, get it started right now. So we pretty much just dove headfirst into systemd because it really provided us everything we needed, as opposed to the classic init scripts approach or sysv scripts approach, which sometimes even lied. I can't tell you how many times a sysv script would return success when something was dead. And these are things that at least systemd is more aware of because it has a full understanding of the life cycle of a process. So I mentioned earlier that what we were really focusing on too here is, as opposed to the mistakes we made with the Matahari project, we really wanted to build on top of known existing standards. And so what we did was we took a look at the manageability world as a whole and saw what our competitors were doing and what other industries were using for this technology. And what we settled on was DMTF SIM. DMTF, it's a distributed management task force standard written around the Common Information Model. It's used by IBM in its end-to-end management suite, proprietary management suite. It's used by Microsoft in its PowerShell and System Console functionality. It's used by Dell to manage its iDRAC 7 system, which is the the BMC then the EFI system for their servers. It's used by many storage vendors to manipulate SAN and NAS machines remotely. What makes SIM really neat is actually that this common model is very comprehensive. It was developed over almost a decade, and it really does address very close to everything that one might ever want to manage on a server system. And not just a Linux system, or not just a Unix system, but a system as a concept. Now, I don't know if there's anyone, has anyone in this room ever used SIM in the past? Yeah, I could guess that you did, because when I mentioned it, all three of you winced. And yes, there's a reason for that, and that's that the SIM protocols and the DMTF models are very complex in order to achieve that comprehensiveness. So how do we solve that? Because I started this conversation by saying that one of our goals was, in fact, to make this simplistic and accessible to a junior admin. So the way that we're going to do that is we've started building another tool on top of OpenLMI called the LMI shell. Now, what the LMI shell is it's a Python language. It's written in the Python language. It is usable as Python, but it's a series of essentially helper scripts, and which we call scriptons, that are designed to take the complexity away and abstract out the 80% case of the SIM model. So what we want to do is build up this library of scriptons, this library of very simple, tiny pieces, functions in a programmer's term, that will address most of the really important things. Instead of, for example, if you wanted to set up a RAID array, having to take two block device objects and create an association that corresponded to a RAID 0 association, and in SIM, which is a complicated idea, we can wrap those in a script whose job it is to just say, take an array of devices and make them into a RAID array. And under the hood, it'll talk SIM to the managed server and take away a lot of that complexity. And I think I covered a lot of my next slide already. But they're not. The thing about the scriptons that is important is that they're really not meant to be standalone devices. They're meant to be just these chunks of readily reusable and readily shareable code that administrators can use as part of much larger scripts to accomplish a real task. And what we're going to be working on is we're going to be building up a public community that's not dissimilar to the way that Microsoft has its PowerShell scriptlets community, where there are quite a lot of useful little scripts just shared by admins out there that makes things easier for the junior admins in the Microsoft world. We want to solve that same problem, and in much the same way. So with all that in mind, we have a lot of goals here, and we have a lot of ideas for how to get to them. But we do have some limitations right now. We have some limitations in the underlying technology. The major one I have to bring up is because we've standardized on this Blivet library, which started as part of Anaconda. It's very, very, very heavily weighted towards initial setup tasks, things like creating a partition, things like destroying, creating a complete file system, or sorry, a complete partition table, destroying all of your partitions in order to create new ones. And it's kind of weak on some of the more runtime type of things, such as extending a partition, taking an LVM snapshot, shrinking a partition if you ever were so foolish. And these are places that, unfortunately, right now the Blivet library kind of falls down. And part of why I'm here today is I'm really trying to find some support, not just at Red Hat, where we've pretty much around the board agreed that this is the place we want to go. But I want to get some help from you guys, because frankly, some of the best engineers in the world are sitting in this room, and that's exactly the sort of people we want helping on stuff like this. So if you have familiarity with Python and familiarity with storage, I really encourage you to get involved with the Blivet project. It's not, people are falsely assuming right now that it's very much a Red Hat only project because it came out of Anaconda and therefore, well, Anaconda is only used by Red Hat. But most of the Blivet project is very much portable over to Ubuntu. It's portable over to SUSE. I don't think anyone has done it yet, but there is very little preventing it from being done. And I would love to see some of you folks assist with that if you could.
I'll just point out, Steve, we are actually in the Blivet team. The Anaconda developers are working with Lukasz Cherner on Storage System Manager as well, because they're both Anaconda.
Would you mind repeating that?
Yeah, so I was just going to point out that the Blivet developers are working with Lukasz Cherner, Hannes Reinecke, and other people across distro and Storage System Manager, which is also in Python, to try to incorporate some of the common use cases for file and storage systems. So there is some sharing that's community-wide, and we're trying to figure out where all that code lives and try to get it into a common reusable place.
Probably just curious why not SSM storage doing glue and stuff.
I'm sorry?
Well, I'm just curiously asking if the SSM storage work and then the Blivet storage work seem like, in some ways, trying to solve the same kind of problems. Would it make sense to just make them one project and then you derive your Anaconda benefit out of it? And
negotiations are ongoing to accomplish basically that.
Well, I'd say, I mean, storage system SSM is a CLI, and Blivet's more of a Python set of libraries. So effectively, you could think of SSM as the CLI version of Blivet for storage.
So yeah, there's a possibility at some point that what we will have is SSM powered by Blivet. There is also work going on towards taking some of the Pythonisms of Blivet and making it into a C API as well. But that's long term because right now what we have works. So we have a couple of other things that we're not terribly efficient at yet in the OpenLMI project. We're having right now we actually have an ongoing debate as to how to model and how to present things like network storage, such as iSCSI and FCoE and fiber channel and multipath and so on and so forth. And that's an opportunity that I would like to invite you to come join the OpenLMI community and help us figure out what is the right modeling for this. Because some of these things are not particularly well modeled by the DMTF. That was where I was saying that it covers most of what we want to do, but not quite everything. Another example is that the DMTF models didn't have any concept of an encrypted file system in the way that we do encrypt setup in Lux. So we had to write our own models for those things. Another piece that's pretty common across the board is patch management. One thing that we find that customers really want to know is, I've got these 150,000 systems. Do all of them have this CVE on them, this CVE fix on them? And that's not something that most of our distributions can do particularly well yet, because there's there are problems at the low level. In the case of RPM, where we don't necessarily have metadata that supports that, and that and there's cases, or we could move it out of the package itself and be talking about the distributed mechanism of yum or apt or whichever, I don't know what SUSE uses. But what we'd really like to do is actually find a way to put together that information and make sure that we know that this patch rolls up, that every package patch rolls up all of the previous ones, and that we can ask a bank of systems, is the fix for this installed? And if not, fix that problem immediately. And so these are some places where OpenLMI has a pretty good idea of what the API needs to look like, but the underlying technologies, and of course the abstraction for the different formats like yum and apt and so on, really need a lot of love and care. So we're pretty sure we can present it right, but we just can't do it right now. So how can you help? Well, the short answer is, of course, any way you're willing. This is a very young project, but I think it's a very important project. It's a way to really make Linux explode in the server market, to really make it just the best, just a better choice all around than any of its competition. And I'm not just talking about Red Hat. I'm talking about SUSE. I'm talking about Canonical's Ubuntu. I'm talking Mandriva, and I'm talking any other distribution out there that wants to have a piece of the DevOps world, a piece of the Amazon cloud. So the ways that I see that you can help as engineers, first, if you're writing one of these subsystems that you think deserves to be managed publicly, deserves to be managed remotely and centrally, help us write an API, and a consistent API, like what we did with NetworkManager to solve the network scripts problem. Help us, and what we're doing with Blivet to solve the storage problem. Help us write a public API that the OpenLMI project can talk to and abstract, that does the work and does it in a way that you can say with reasonable confidence, I'm not going to break my system if I mistype this. It's just going to fail. Things like that. If you're not a subsystem writer, but you're interested in the administration side of things, we'd really, really like some help developing these scriptings, and not necessarily writing the code for them, but come to us and say, these are the tasks that I have the most trouble doing in the existing format. These are the tasks that it's really, really, really hard to create a 13 drive RAID 1 array. Actually, that's a bad example, but I want to be able to do that, and I want to be able to do that with a single function call, effectively, a single scripting. Just help us figure out what those goals are. What do we need to meet in order to make that work? Right now, we're also doing. There are a couple of places where we looked at the DMTF API, the DMTF schema, and it just doesn't work. It doesn't make sense. There are places where, we after we decided that we were adopting SIM, we went and we had conversations with a variety of vendors. For example, some of the networking vendors, and we're told, well, nobody but Citrix uses the DMTF standard for networking. Why? Cisco wrote it. Oh, sorry, Citrix wrote it, and they kind of co-opted it, and no one else had any input into it. So it doesn't meet the needs of most people. So and we found the same was true for us. So right now we're in the middle of designing a new SIM model for networking, and that's up for review on the OpenLMI mailing list today, as it happens, and has been for about a week now. So we would really like to, if you're interested at all in this, we'd like to know, does our model for how this looks make sense to you, and does it, and can we make it a little easier? Because if we're going to be writing our own, there's no reason it needs to be anywhere near as complicated as the DMTF. We can build what works and then extend it when we need to. So.
And just one comment on in terms of
Just a second. We get you the mic.
In terms of building useful abstractions for any kind of new device that keeps coming up, and you always will have different ways to configure it, and with convergence and all these technologies, the Linux always has this problem that there is no layer that you talk to, and so you really just write wraparounds, and each has its own set of libraries. So from a long-term perspective, I would also see if you want to have any kind of initiative in which a user space to kernel space layer is there. So folks who want to write for a new technology are actually writing to that layer as well.
I agree completely. I don't really have a lot to add to that. That level of the conversation is a little bit outside my area of expertise. So, however, it's not for this group. So I certainly encourage you to have a conversation after this session. See where we can go with that. Now, in terms of, obviously, I'm up here, essentially begging for help. This project, and as I've been talking, I can at least see from most of the people I'm talking to, I'm seeing a lot of nods, and I'm seeing a lot of, yeah, that's something we really do want to do. So if you do want to help, or if you know someone that could help, please get them to try out what we've got so far. We've got a a mostly working proof of concept that's out in the Fedora 18 updates testing, updates repository, and I think a couple of pieces landed the last couple of days in updates testing for how to do some of the storage stuff and how to do some of the networking stuff and how to do a lot of actually I think all of the system services stuff that we planned on doing for the first iteration are done. And I would really like to see that download count go up. I'd like to see that people are starting to report bugs. I'd like to see that people joining the mailing list, and I'll have a link to that on a later slide. And I really feel that this is a project that simultaneously is cool and would be exciting to be a part of, and it's really necessary. It really is the way that we're going to get past the particular plateau that Linux as an OS is in right now. So, with that in mind, I'd like to open up for questions.
So the reason why my first answer to you was that I go Google something to figure out how to do it is that the administrative model on the different distros is different. And it's something that drives me absolutely bats. That I use a distro for a couple days and remember where the config files are, and then because I'm developing software that needs to run on multiple distros, I have a bunch of machines running multiple distros. So maybe you can say a little bit about how much of, because you mentioned a lot during your talk about the difference between dealing with RPMs and .debs and things like that. Maybe you talk a little bit about how much of this is cross-distro right now.
Right now, unfortunately, the answer is very little of it, because as I started with, this is a project that originated out of Red Hat, currently is staffed entirely by Red Hat, there's one fellow from SUSE who's fairly active on the mailing list who's helping us make decisions on what the external API should look like. At this particular moment, and that's why I'm here asking for help, we would really like to get some of the other some contributors from other distros, because that is a goal. It really is our intent for this not to be the way that we manage RHEL systems. It's not the way that we manage Fedora systems, because who manages Fedora systems? It's the way that we want people to manage Linux OS systems, or GNU Linux, however you prefer it to be said. We really do want this to be the abstraction layer that people have been looking for since the dawn of time, or at least the dawn of the epoch.
Oh, so that's great. That's a great answer. And the other, so it's kind of a follow-on question then is some of the, I'm not sure what I'd call them, I guess the major Linux OEMs, in other words, people who make systems that run Linux and sell them, like HP and Dell, have their own manageability frameworks. And I know from past experience that the last thing they want is another framework. They want something that plugs into their framework. So can you also maybe talk about that a little bit? Is that a goal of yours?
Not only is it a goal, it's one that we are actively pursuing. We are actually in talks with both Hewlett-Packard and Dell at the moment. What we want...
I can validate that.
Yes. We are looking at ways that we can provide access to the Dell iDRAC 7, or I forget what HP calls its BMC, but and its storage options. That we can do those through using OpenLMI. We're investigating a couple of options. One is by way of proxy, so that we would present one interface in OpenLMI that under the hood would be communicating using their existing SIM interface, or just simply presenting their SIM interface as part of the same communication channel that you're using with OpenLMI, which is the details of that are still being worked out, but the fact is they are being worked out.
And there are, I mean,
sorry.
And I will say there are other components in the stack. So this is kind of a fairly high-level abstraction. There's things way down the stack, like lib storage management, which has been presented at different Linux cons, which is working closely with vendors and HBA vendors and so on. That can talk directly to vendor proprietary binaries without having them to open source their parts. Right.
Yeah.
And then we'll be consuming that up the stack and pulling that into Blivet.
So there's a question out back here.
What are you doing about security?
Can you remind me?
What are you doing about access security?
Okay, that's a good question. We do have the model right now is a bit simplistic. What we've got is essentially an all or nothing level of security, which is done by the protocol over which we talk SIM is done by HTTP, and right now we're basically limited to certain specific HTTP authentication mechanisms, which are HTTP basic over SSL, or mutual certificate authentication, which is much more secure. We are also actively pursuing extending the SIMOM protocol language so that it supports SASL GSS API. We've got a group of people working on that pretty intently. As far as individual model level controls, we don't have. We can only get that right now at the namespace level. For those of you who understand SIM, that's a very broad level, and the reason for that is actually just that the SIM model is not designed for it, because there are so many interactions between models that saying, okay, you can do storage but not networking means that you have completely eliminated your ability to do iSCSI, for example, because all of the models interact in such a way that we haven't yet figured out a good way to divide and conquer them.
In my experience, one thing that is hard about putting other layers on top of commands and things like that, and wrappers and stuff like that, is error propagation. You've got a script that runs 5 sub-commands. One of them fails. Don't know which one. You get the Microsoft-esque error. Something bad happened. Sorry. How do you have a framework for communicating the errors up the stack in a meaningful way so that the user knows why a particular script failed or whatever?
Yeah. Well, at the moment, one thing that the SIM protocol limits us to is that most actions are actually synchronous. So when an error happens, it's usually not happening. It's usually pretty easy to tell that, okay, well, we just don't go on to the next one. There are some asynchronous actions, and the SIM protocol allows us to do something called indicators, which, if you're familiar with dbus, they're not too dissimilar from signals. So we do really know. We do have the capability of knowing in the model that if something failed here, we really can notify the client that it happened here. In many cases, it's going to end up being a combination of the underlying subsystem to store logging information and the consumer to say, okay, it failed here, present it properly. But we do have the ability to know pretty much where in the SIM model things failed.
One more. Another question.
Yep.
So another thing that has come up with me in the past with manageability frameworks, none of which have the broad goals that yours have, but even NetworkManager has failed me in this way, is that if I do know how to go do something and I go edit the files, I confuse the tool. Right? In other words, you either have to decide that you're going to use the tool or not. The worst case being like you add a user by hand and then you use another tool to add the user and it duplicates the UID or it does something just really stupid, right? Because all those files are parsable. And so I guess I'd like to hear that maybe your little script-ons have rules about not assuming they're the only way that these changes get made.
It's not. We're intentionally avoiding answering that problem because the goal, our goal with this is to be driving the subsystems to solve that problem. If, for example, NetworkManager 0.9 now has some capability to at least acknowledge that this particular set of functionality is not managed by NetworkManager but can be reported. So it would go into a read-only mode for that option, and so we would get an error trying to modify it once it had been hand modified, but but we wouldn't ever continue believing that it was behaving the way it used to. So the state would be consistent, just stop being modifiable, and that's the sort of pattern that we're recommending that move on to other subsystems. That way, we can't solve every problem because there is an infinite number of ways that someone can screw up.
Sure, in the face of errors, but sysadmins are allowed to go edit those files. You shouldn't stop being able to manage using your tool just because they correctly modified a file.
And I don't disagree with you. but it's not the right layer at OpenLMI to solve that problem. If we've decided that we're standardizing on NetworkManager, for example, because it provides the API we need, then to us, it's NetworkManager's problem to make sure that it properly handles when someone manually modifies the file.
I see.
Any other questions? All right, well, far be it from me to stand between you and lunch. Thank you very much for listening.